All right, just a video to walk through this activity, transformations, take you through the example, and then you'll have time to work on the assignment. So this is given a raw set of data, context, age of lumberjack in years versus average number of trees that were cut down. So we want to do a few things. First, we want to get an idea of what the graph is going to look like. So we're going to create scatter plots. So insert chart, scatter plot. Sometimes, and I don't know why this is the case. Sometimes it comes up with the labels and sometimes it doesn't. So I'm going to do a quick edit here. Horizontal axis, I'll just put age just to keep it simple. Vertical axis, I'm going to put number of trees. All right, just to have that appropriately labeled, because it's a requirement generally when you create a graph that you have the appropriate labels on it. All right, we're going to figure out the y-intercept. We can get that from the customization menu, but if we want to come up with predicted values, it's nicer to have these numbers in a separate tab. So intercept, always the y column first, followed by the x column. Reject that. I'm going to do slope equals slope. Same deal. Y column.
Johnny Rudin, please come to the main office.
X value. This is like actually my fourth attempt trying to make a video on this because of things like that, interruptions, loudspeakers, stuff like that. So just kind of bear with me. All right, R squared value, Corel, right on cue. So that's correlation, but it looks like it says Corel. Now that correlation is just the R value. I want the R squared value. So I'm going to slap on a power of 2 here. All right, and then I'll lock it in. All right, my predicted values are going to be equal to, this is a linear equation, so it's equal to what I would get if I took my y-intercept, added to it my slope multiplied by this first value here. Now, we want to get some dollar signs on the rows because when I slide this down the line, I don't want 17 becoming 18, becoming 19, and so on. So I'm going to lock that in. I do want to keep my A8 variable, so leave that alone. The suggested autofill seems okay. All right, you can double check each one, but generally, I mean, this looks, it's definitely a curved relation, but it looks like you can get a line through most of the points. So your predicted value should be in the neighborhood of what the actual values are, the average number of trees cut down. So I feel pretty good about that. Now, for a residual plot, what I want to do is take my age of lumberjacks in years again. I personally like to have references, right? So where I have age of lumberjacks here, I typed it here, but I could also do equals A7 and let it do it that way. You might want to change the formatting a little bit, but that's up to you. And when I do that and I drag this down the line, all those values are replicated in my list. Right? You don't have to worry about the fact that the yellow highlight went away because, I mean, you put it back if it's something that you want to do, but the yellow highlight is where your responses should be. So I just look at your spreadsheet and I see, okay, there are numbers here. Yeah, it's not highlighted in yellow, but that's not the point. It's, you answered the question, so it's good. The residual values are the observed values minus the predicted values. So in this case, I'm going to do equals this number minus this number. Hit enter. It overshoots it, so I don't really trust this so much. So I'll manually do it. All right. And then I'm going to create a plot out of this information. All right. So insert chart. Got my scatter plot, which for some reason this time got labeled. I cannot figure out for the life of me why. Right? Here's my residual plot. I'm gonna kind of try to keep it in alignment somewhat. Doesn't have to be perfect, but you know, the nicer it is, the more organized it is, the easier it is for me to grade it, right, or to evaluate it. You know, just for giggles here, I'm gonna re-highlight this in yellow. All right. Do I see a pattern in the residual plot? I do. So I'm going to select yes. So this model is likely not appropriate. And we learned previously that it's entirely possible that you go through all the different possible ways of evaluating data, and none of them are ideal, but one's got to be better than the rest. So I see a very pronounced pattern here. And my R value is my R squared value is 0.841. I want my R squared value to be as close to 1 as possible, because the closer it is to 1, the closer it is to a perfect fit. All right, so that's my linear analysis. Now I want to move on to an exponential. That's where this table comes into play. For an exponential model, what we do is we take our dependent variable and we slap a log on it. All right, so here, my age is still the same, so equals whatever I have in A8. Drag it on down the line. I'm going to take the log of the number of trees. So log 10 is the one that we want. That's the base 10 logarithm of that first entry. It gives a suggested autofill, so I'll believe it. All right. What I want to now do is create a scatter plot for this new transform data. So insert chart. All right. Again, this time it labeled it. The first time it didn't. So just, I guess, you can probably get excited, I guess, or like, oh, it labeled it for me. That was nice, So kind of appreciate it when it happens, because it won't always happen. All right, so that's my scatter plot. Looks a little bit more linear than the previous one. I resized it so it was roughly the same size. You don't really need the chart title if you don't want, right? It does tend to take up some space, so I can get that out of there. And just make sure my sizing, because I want to do an apples to apples comparison. So having the charts be the same size is helpful, because if this one is more compressed, like if I do it like this, you might think it's more linear, but that's not the case. Necessarily is what I should say. It does look like it has less of a curve now than it did before, so maybe this is a good model. So I need my y-intercept for these values, so I'm actually going to do the same stuff. Copy this over, paste. Just make sure it points to the right stuff. If it does, then another thing to be happy about, because it's less work, right? And that's one of the reasons why we have to have a pretty organized approach when it comes to this stuff, because if the relationship between, like, let's say y-intercept is such that it's looking at B8 to B15, which are these values here, in comparison to this one, which is referencing these values here, you see the positioning within the spreadsheet are the same. So Google Sheets is going to assume that when I paste over here that I'm looking for this column, right? Among others, so both columns in one shot, all right? So having a structured approach makes things a little nicer. Same idea with predicted. So let me do that. Let's see what happens. It gave me a number. Doesn't mean the number's right. I look at what it did. It's pointing to my I-17, which is the y-intercept, plus my slope, times whatever that value is. So based off of those row column references relationships, I'm able to, with minimal work, get my predicted values. All right. Same idea here. My age, that goes right back to A8, so equals A8. And let me undo that. Let's take a stab at it. I'm going to copy this over, paste it, and see what it does. Now it's pointing to H8, which I kind of like going back to the original one, but I can live with that. All right, so it's taking this column right here. And then my residuals, are they pointing to the right thing? They are, so copy paste worked out for me here, right? Not quite the same with a graph. Like if I do that and I paste it over here, it's producing the same graph. So that's not something that you can look to do. And that's just the nature of it, because this isn't locked in on any particular cell, so there's no way it can have a corresponding relationship with this information over here and this information over here. So unfortunately, that's something you got to do from square one here. So insert chart, although if it's continuing to be nice and labeling it for me, I'm not feeling very bad about this process. Now, in this case, and you see these little red lines that appear, that's helpful for alignment. It lets me know that it's in alignment with the graph to the left and the graph above it. And that's what I want. You see that it does have the same general shape, but the curve is less pronounced. So yeah, I see a pattern in the residual plot, and by definition, that means that this model's probably not appropriate, but it's definitely more appropriate than the linear because my curve is less pronounced. Now, in terms of the R-squared values, not that doesn't really support that claim, right? So if I had to choose between just these two models, I don't know that I would be able to make the choice, because this one has a better R-squared value than this one, but this one has a better residual plot slightly. Right, this one is residual plot slightly better than this one, so it's kind of up in the air. What that usually means is let's see if we could find a different option. So then we go to a quadratic transformation. All right, so I'm going to go right back to my A8, grab that entry. Now I'm going to take the square root of the average number of trees that were cut down. So back to my raw data here, I'm going to take the square root of each of these numbers. So I can do that by equals SQRT square root of, it's in B8, but I just want to click on it. All right. Now it makes a suggestion. If you feel confident, then you can do that. All right. These shouldn't be here just yet. All right. So I need my graph. Insert chart. Let's get a resize here. You see those little blue lines that appeared? That's telling me that this graph has the same dimensions as the nearest one, right? And again, get rid of the title if you want. Still has the same dimensions. See that red line that appears? I could put, right here is fine, I guess. This looks like it's even smoother than this one, less of a curve to it. So feeling pretty good about this. My y-intercept, same deal. You could try to copy paste. We'll end up with a little issue here, maybe, I think, if I remember correctly. Let's see. No issue whatsoever. It worked out beautifully. All right, yeah, and that's because the relative position between these cells and these cells is consistent based off of the layout. So that's good. R-squared value is slightly better. So far, the linear R-squared value is the best one out of all of them. But looking at this one, it looks like it's kind of more linear. So it's kind of surprising that that's the case, but we will play it out and see how it goes. I'm going to copy this. Actually, let me copy the entire chunk and see if it does it the way I want it to do. Is it pointing to the right stuff? Now you see, because I have the dollar signs here, it's pointing back to these numbers, which I don't want. I want it to be 4748 rather than 1718. I mean, it feels like this is an awful lot like guess and check, and it's not really wrong to think of it that way, because that's what's happening. I mean, unless you want to retype every line command every single time, most of the time what you do is you do a little copy paste and see if it points to the right stuff. All right, so my R-squared value is not great, but let's get my age of lumberjacks in here again, so A8. So I actually want this You see how I'm doing A8 instead of just typing in the numbers or copy pasting. I want this to be cell references because the best thing that you can do with a sheet, whether it's Excel or Google, is make it flexible to the point where instead of you having to update every single thing whenever you import new data, you want it to be that if you change one data point, let's make this 10 of 5, it changes across the board, right? And that's a time saver, right? It's introducing a little bit of automation to things, right? And automation is a complicated concept, but there's some small things that we can do to make our lives easier. So if I have a data set that only has, I think there's 8 values here, 1, 2, 3, 4, 5, 6, 7, 8. If I have another data set that has only 8 values in it, I could just overwrite the data in here and everything's going to change along with it. I'll have to change my drop downs, but that's not the end of the world, right? So that's something that, it's a nice feature that you should learn how to rely on and verify, right? So I did a little copy paste. It looks like it's pointing to the right stuff, so I feel good about it. I'm going to grab my insert chart. It labeled it again. It must really like residual plots. Well, actually, no, that's not even true because it did this one all right also. I can't wrap my head around why it labels some and it just arbitrarily stops labeling. All right, you'll probably hear me say that 7 or 8 more times before this is over. So, yep, there's definitely a pattern here. 0.791 is not as good as the linear case. All right, so it's down to logarithmic. No, that should be logarithmic. All right, so we're going to do the log. This time we're actually changing the x values and leaving the y's alone. So in this case, I'm going to do the log 10 of every entry in my X column, my age of lumberjacks. And you can see here it says independent variable log X. All right, independent variable is the first variable, and the dependent is the second because the second changes based off what happens in the first. All right, but long story short, I'm going to click on that and then hit enter or if I needed to edit further, I could do that. But yeah, just lock it in. My average number of trees cut down, that was in B8. Feel good about that. Same deal. Let's make a scatter plot, insert chart. It labeled it. And again, as long as you have kind of an apples to apples, you're fine. For these original graphs, I've been taking off the chart title. The residual plot's not quite as important. So I'm going to do that, wipe that out. And I'm looking at something here that looks very linear, right, in comparison to the other ones. Right, maybe 1 or 2 points in this neck of the woods that are a little out of whack, but this looks pretty good. All right, so I'm still going to do the same thing with my slopes and my y-intercepts and all that good stuff. Make sure it points to the right stuff. Looks good. Look at that R-squared value. Practically perfect. Well, maybe not. Very, very close to perfect, though. All right, so I can get my predicted. Let's see here, pointing to the right stuff. It sure is. And we don't have to update the row references because we're still in the same row from the copy to the paste. So that's good news. Same idea with residuals. Make sure, I always double check, make sure it points to the right stuff. It's just an extra click. It'd be foolish not to double check. Then create my graph chart. Now, so this one's kind of strange. I mean, in the case of, let's say, the quadratic, for example, where are you, quadratic? That's this one. So I see a very pronounced pattern here, right? In this case, I see what could be a pattern, but I'm not sure. Now, if I expand this one and make it bigger, I still see a pattern here, right? Whereas in this case, I don't really see a pattern. I mean, maybe make a case that it's something like this, but it just doesn't feel like as much of a pattern. But when I resize it and make it smaller, sometimes a relationship that doesn't really exist might appear. So you might look at this and say, well, now I see a pattern. What I would say is make it a first impression kind of thing. So if at first glance, your first impression is, I see a pattern, then you see a pattern. If your first impression is, I'm not sure, then you don't see a pattern, right? So that it's one of those things like, look at it immediately and say, pattern, yes or no. If the answer is anything other than yes immediately, probably going to go with a no, all right? Now, even if we went no on this one, you could also kind of look at it and say, well, does that really even matter? Because look at this r squared value. It's so close to 1 that this is the one I'm going to select anyway. So you can go yes or no. I initially didn't see a pattern, but then when I resize it, I see one. That's also something to consider. Look for the pattern before you resize it. Because like I said before, I'm going to say I don't see a pattern here. Like I said before, if I compress it enough, you can kind of convince yourself of anything. Look, it all falls on the same straight line. Right? That's not really the case. It's just the way it got scaled. Right? And that's some of the trickery that comes into statistics. You know, that people will do stuff like that. They'll scale graphs in a way to make you think something is happening when it really isn't. All right, so just stuff to keep in mind. So we looked at all the different models and look at all this work on this page. It took a few minutes, but now, like I said, if I change through all my references, if I change one number, you see how it gets changed across the board. The graphs change with it, everything. All right, so that's the beauty of doing it this way rather than doing it in like a graphing calculator. All right, so which model? I would say the logarithmic. Why didn't, you could write it any way you want, but I'm saying didn't see a pattern in the residual plot. The r squared value was close to 1. Now, if you did see a pattern, then you would say, I saw a pattern, but the r squared was closest to 1. Sorry, closest to 1. This is some kind of reference that I don't remember putting in there. But while we have it, the r squared value that's relevant here is located in cell I49. Okay, so it must have been left over from the last time I worked out this example. All right, so what is the equation of the best fit model? All right, so now that we settled on which model was best, I'm going to look at my chart up here. Independent variable, log of x. Your model should be in the form of, I think I'm missing a coefficient here. All right, I'll have to edit that. It should be in the form of a plus b log x. So the linear equation, a plus bx, y-intercept, slope, x value. Here it's same idea, just slap a log in front of the x. All right, so I'm going to say y equals, and my y, let's get specific like we did in the previous activity. The number of trees, I'll say num trees. You can, any abbreviation that makes sense is fine. All right, the slope, that's this number here, so 16.63, oh, sorry, we want y-intercept, negative 9.926, so negative 9.926 plus my slope, 16.635, times log. I usually use a capital L when I say log because it looks like a 1 if I don't. and the log of whatever the x variable is. In this case, again, it's age. All right. So now if I wanted, it's not asking for this, but if I wanted to predict the number of trees that a person who is 25 years old, 30 years old, 70 years old, whatever, would be able to cut down, I now know that if I use this function, all I have to do is replace age with whatever age I'm considering. All right. So that should get you good and ready to go on to the assignment. So have at it. And yeah, thank you.